Hi, everybody. My name is Lindsey Henderson, and I am the Secondary Math Specialist for the Utah State Board of Education. And I'm really excited to be joining you today to talk about increasing opportunities to learn and raising expectations for all. And we are going to focus in on what I like to call the Utah way. So we're going to start off our conversation today talking about Utah's secondary mathematics pathways. Utah is a unique state in several ways, and I'm going to highlight those. The first way that we are unique is we are one of 3 states in the United States that has integrated high school standards that are mandatory in the entire state. I know there are several states that allow their districts autonomy to choose if they want to teach on an algebra, geometry, algebra 2 sequence, or if they want to do an integrated math pathway. Utah is a state where it is mandatory that we teach integrated standards everywhere in all of our public high schools and charter schools. And so starting in 9th grade, all students take secondary math 1, unless there's a small subset of students that get accelerated sometime in, usually junior high is the place where students make a choice about whether or not to accelerate. And so students have an option to take secondary math 1, secondary math 2, and secondary math 3. That's 9th grade, 10th grade, 11th grade year. We are a 3 years to graduate state, and by the time students reach their junior year and they've taken secondary 1, 2, and 3, they've completed their graduation requirements. You'll notice on this document that we also have that blue column called extended topics. So students can choose, that's what the choice arrow means between the 2 pathways, is that students and families have choice to decide if they want to take the foundation courses, secondary math 1, 2, and 3, or if students are interested in taking the extended topics, which include the secondary math 1, 2, and 3 topics, but have additional content from pre-calculus. You can see the bullets there underneath each of the headers and see what the additional topics are for the extended topics. We found that about 18% of students in Utah are really interested in taking calculus, particularly AP calculus, their senior year. And so the extended pathway is a way for students who are interested in taking AP calculus to have a direct route to calculus in high school. Now, the other 82% of our student population may at some point find calculus valuable. The question is, though, should they take it in high school or should they take it in college? And so we have the secondary math 1, 2, and 3 foundation courses that lead into some of our early college experiences as a senior. Our board rule that governs graduation requirements is very strongly written so that it requires 3 years to graduate, but students who are interested in pursuing higher education should not have a gap year in high school of mathematics. We strongly encourage them to take 4 years of math in high school. And the senior year is where our stakeholders have decided that students have autonomy to choose which experience they'd like to take in high school. And some of those choices have college credit attached to them, and some of them don't. And they're all wonderful opportunities that we have available for our students. So let's talk a little bit about the link up to our higher ed there. It's the bottom rectangle. Students who take the extended topics generally want to take that AP calculus class as a senior, but they can take any other class in that rectangle that they feel would best fit their aspirations and their needs. Lots of times students will think in 8th grade, they're 13 years old. Ooh, I really want to take calculus. But as they learn and grow and develop, they start enrolling in those extended topics, and then they decide that's not their interest anymore, and they want to switch back to the foundation courses, and vice versa. We have students who are in the foundation courses who get really excited about mathematics and excited about the potential of taking calculus. And so we allow that flexibility for students to change between the 2 pathways at any point in their career and be set up for success to either take calculus or to take a quantitative reasoning, a statistical experience, or a college algebra and trigonometry experience. Our higher ed partners in Utah are very supportive of the dual enrollment and concurrent enrollment opportunities that we have. And they show the support by they've come to consensus about the topics that are taught in each of those 3 buckets: quantitative reasoning, statistics, college algebra, and trigonometry. And then they've also come together to make all the numbering the same across all institutions of higher education in Utah. So if a student has Math 1030 on their transcript from a Utah university, I know that that is quantitative reasoning regardless of the institution of higher education that they attended. One thing that's unique about our pathways is not only the integrated standards, but we also have secondary Math 3 in our board rule. Parents can write a letter to the district or the school and request that their student gets opted out from that secondary Math 3 content. And you can see that secondary Math 3 is polynomials, rationals, radical functions, trig, logarithms, and some data collection and analysis. So parents can write the letter, their student can be opted out of secondary Math 3, and then students still have to take a third-year math course to fulfill graduation requirements, and that's where the rectangle on the top left comes in. It's called Alternative Sections, Prerequisite Secondary Math 2. And students need to take, the prerequisite mostly indicates when this class needs to be taken. It needs to be taken the third year of high school. Some of these classes, like computer programming, if you're not taking them for math graduation credit, you can take them during your 9th grade year. Another piece of our secondary math ecosystem that's really unique is in high school in Utah. It's actually in all grade levels, but I find it's most unique in a high school setting. We advance all students with their grade level peers. And I'm going to just pause for a minute because I want to let that sink in. Maybe I'll repeat it. We advance all students in Utah with their grade level peers, period. End of story. Not if they passed the previous year's math class, which is the system that I graduated under. So all 9th grade students take secondary Math 1. Regardless of their performance, they're enrolled in secondary Math 2 as a 10th grader. We in Utah found that, put up this slide, we used Hattie's effect sizes to look at retention. And if you look at that list, the bar down in the red, retention, holding students back. Retention has a negative 0.32 effect size. And if you look at the graph on the right, the zone of desired effects for an implementation or an effort starts at 0.4. And already retention has a negative effect size. It's in that red bar that says it has reverse desired effects. It is harmful to students. It does not do them any services, and it can be very damaging to a student's identity. So in Utah, all students advance with their grade level peers. Now, we understand that there are certain times when students need extra additional supports and structures in place, and we do not ignore that. We do not gloss over that at all. We leave it up to our wonderful partners at districts and department heads and teachers to decide, what does student struggle look like in your student population? What is the evidence you can collect? And at the first sign of student struggle in a high school math class, a student should be given the opportunity to be enrolled in what we call a just-in-time support course. Now, there are a couple of things they have to give up to enroll in a just-in-time support course. We commonly call them math labs in high school. A student has to give up an elective to take this course. And so we've tried to incentivize that in a way that helps attract students so that they can be successful in their math class. There's also the structure of the just-in-time support course. This is not a homework help class. This is a class that surfaces students' funds of knowledge and works to bridge those funds of knowledge to grade level content to provide equitable access to rigor. I'm going to go back to the slide about our secondary math pathways. When we organized which topics go in which course, our committees were very focused on not making this a linear trajectory. You do not have to have secondary math 1 to be successful in secondary math 2. You can enter at any point and you can be successful. The same goes for students who do not pass particular sections of their secondary math experience. We at no time want a Utah student to experience an unsuccessful year ever. We do not want a student to fail the entire year. We want the first sign of struggle for this just-in-time support course to come into play and to help enrich that student's math experience and help to shore them up and give them the skills that they need so that they can be exited out of the just-in-time support course when needed and placed into their credit-bearing math course and be a successful human being. So our standards are our topics are divided up so that we honor the idea that math is a big, messy web of ideas. They're all interconnected. They all have wonderful applications. And some of the web of ideas is more interesting to individuals than other parts of the web of mathematical ideas. And so secondary math 1 is kind of over here in the web. Secondary math 2 is over here. And our teachers are not only drawing connections because of the integrated standards between the major strands within the class, but they're also drawing connections across the secondary math 1, 2, and 3 experience. There are skills that you learn in secondary math 1 about linear equations and exponential equations that will translate to quadratic functions. And it doesn't mean that you have to have had experience with linears and exponentials to understand quadratics. It helps. And that's what the purpose of the just-in-time support courses are, to help students draw those intentional connections that they need to make in the big, messy web of mathematical ideas so that they can be just realize their mathematical excellence by the time they graduate high school. So the first statistic that I really want to highlight is that upper left corner, additional math credits. We are 3 years to graduate, 3 years of math to graduate high school state. And since we switched from algebra, geometry, algebra 2 to secondary 1, 2, and 3, we have seen almost triple percentages of students who volunteer to take a 4th year math course and earn the credit. That's an amazing outcome. There's lots of evidence and research that says any gap year in high school leads to not great outcomes when students transfer into universities and colleges. The second piece of data that I want to highlight is right next to the additional math credits. It's called course completion. It looks like a target symbol. In 2012, when we were on the algebra, geometry, algebra 2 system, we only had 43% of students with disabilities earning their 9th grade math credit. Since we've changed to secondary 1, 2, and 3, we have 85% of students in 2020, of students with disabilities in the year 2020 graduating with their 9th grade math credit. Amazing, amazing. It's hard to attribute any one thing from our system to these successful outcomes. And so I just like to highlight some of the things that I think are unique about our system that sets us apart, that sets us up for really great student success. Okay, so after students take secondary math 1, 2, and 3, we showed on that infographic earlier how they can choose from a quantitative reasoning course, statistics course, or a college algebra course. We've really decided to put the decision-making into and empower our students and our families to make choices based on their students' interest and aspirations. This document was created with our work with CBMS and the Dana Center at the University of Texas at Austin. It's called the Launch Years Initiative. And this document helps to get all of our higher ed partners on board with the common numbering systems, as well as the common topics that are taught in each of those classes. And then they aligned it to all of the majors that students might be interested in pursuing in their college career. So you'll look here, Math 1030 is quantitative reasoning, Math 1040 is statistics, and Math 1050 is college algebra, that calculus track that's so important for our students. So we really have opened it up to these courses that is not a hierarchy. This is choices based on what you want to do with your life. If you are interested in English, languages, fine arts, humanities, performing arts, the math experience, the credit-bearing first-year college math experience that will best serve you is quantitative reasoning. And all of our higher ed partners are on board. All the colleges within our higher ed accept all of these credits towards these majors. It's wonderful to be in a system where you have a common space to work in, and it does great things for kids to have information about how they can empower themselves for their future. I love to show this infographic because it shows kind of the evolution of our dual enrollment system over time in Utah. So you'll remember that 1050 is college algebra, 1030 is quantitative reasoning, 1040 is statistics. The first circle is data that was taken when we first implemented this common numbering and that which concurrent enrollment class is right for me based on my interests. And that was 2015. We had data all the way up through the school year 2020. And the size of the circle indicates how many students are enrolled in a dual enrollment class. And then the pieces of the pie tell you which dual enrollment class the students are interested in. If you notice, the size of the circles is increasing over time. We have a lot more students engaging, choosing to take a dual enrollment course and earn college credit in high school through our higher ed partners. Awesome. In 2015, 2016, we had the majority of students taking college algebra. And then you can see that some changes start to get made. And I like to say, and they're changes based on students, right? Having information to choose. So we used this document that I showed before. We started socializing that. And then we saw an interesting, we saw students choosing to take different courses, and still actually the majority is still college algebra. We're not taking anything away from the college algebra experience. We're just offering more options for students to be able to say, I want to take quantitative reasoning. I want to take statistics. And we're leaving that college algebra track in place that's been functioning so well since probably 1945. And it's really awesome to see how if you empower students and families with the right information, that students will actually, they want to make informed choices. They want to do things that help them reach their aspirations. And I feel like this slide really enforces that as well. I'd like to go into a little bit about how we like to train our pre-service teachers to be prepared to teach in the secondary mathematics ecosystem that I talked about. These are all indicators, according to our stakeholders, of a well-trained high school graduate that can transition into being equipped to be an engaged citizen in their community. So this is called Utah's Portrait of a Graduate. These are the 13 characteristics that make up what we feel like is the essential skills that a student should have once they exit high school. And we use this as our guiding document in everything related to students, and everything related to pathways, and everything related to mathematical experiences. It's been really fun as the secondary math specialist to say that academic mastery is just 1/13 of the puzzle. What does it look like to have digital literacy in a secondary math classroom? What does it look like to have hard work and resilience in a secondary math classroom? What does creativity and innovation look like in a secondary math classroom? Those are really fun questions to explore. And so we decided that if those are the qualities that we want all students to have, what are the qualities that we want beginning pre-service teachers to have? And so we assembled a group of stakeholders, and we looked at defining the knowledge, the skills, and the dispositions that it takes for a pre-service teacher to teach the mathematics in high school and middle school the Utah way. And we relied on a lot of documents such as AMTE's Beginning Teachers of Mathematics documents. We use the CBMS's MET2 as well to structure some of our guidance around content knowledge. And we defined these 3 buckets of knowledge, skills, and dispositions for pre-service teachers. From this list of knowledge, skills, and dispositions, I like to call them competencies, we developed a super friendly and welcoming government form about how you're supposed to earn your secondary mathematics endorsement or your middle school mathematics endorsement. And I kind of say this super friendly form tongue-in-cheek, but it's really a fascinating way to showcase what a teacher comes with into our system. So we have 2 areas on this form. All pre-service teachers need to demonstrate competency in content knowledge, and then in their skills and dispositions. And in the first area 1 is the content knowledge. You'll notice, so before we did this endorsement process, which was in 2020, we had a list of courses that teachers needed to take at an accredited higher ed institution in order to get their endorsement. It was It operated fine. It did not leave a lot of options for pre-service teachers to demonstrate their competency in the knowledge, skills, and dispositions. And so you'll notice here's a linear algebra requirement. We have the competencies defined in that document I showed earlier. What does a teacher need to know about linear algebra in order to successfully teach secondary mathematics in high school? And we have the university coursework option, which is perfectly acceptable. And then we have other options as well that teachers can use. We strongly believe about our students in Utah that they bring funds of knowledge to the classroom that are really important. A motto that we have is all students know something mathematically. There is no student in high school that does not know anything. And we feel the same way about our pre-service teachers. All of our pre-service teachers have funds of knowledge that are really important in a secondary mathematics setting, and what are different flexible ways that we can give them in order to demonstrate that competency. So they can take university coursework for content knowledge, they can earn a college degree in mathematics, or they can take an exam to test their content knowledge. In Area 2 in the skills and dispositions, our stakeholders decided that sure, you can take a class on algebra for secondary mathematics teaching. That's awesome. We love our higher ed partners. They do such a wonderful job preparing our pre-service teachers. Some pre-service teachers, that's cost prohibitive. That's the time of the day. They're in the classroom when they're supposed to be taking the class. It doesn't work. And so we opened up other ways for teachers to demonstrate competency in the skills and dispositions. A college degree. If you have mathematics education, you can get a teaching certificate, no questions asked, no additional coursework to take in Utah. Another piece that I think is really important to highlight, we honor the National Board certification process and accept their certificate as competency in the skills and dispositions area for secondary math teachers, pre-service secondary math teachers. We also honor the Presidential Award for Excellence in Mathematics and Science Teaching process, commonly called PAIMST. If a teacher is a finalist or an awardee, they can automatically earn a middle school math endorsement or fulfill the skills and dispositions portion of the secondary mathematics endorsement. We love that program and feel like it is robust and exactly highlights the kind of educational experience that we want students to have in Utah. And then the last piece is we developed micro-credentials. And micro-credentials are kind of just a word that gets thrown around a lot in the zeitgeist right now. In Utah, we've defined them as a way for people to demonstrate their competency with, it's not a course. They are showing us that they are competent in a certain outcome. So we spent time defining the outcomes, and then we asked for 3 pieces of evidence. We asked for evidence of planning, usually a lesson or a unit plan. We ask for evidence of implementation, and we don't want to see a video of teachers lecturing students. We want to see teachers designing a learning experience and students interacting with each other over the learning experience and the teacher guiding the learning towards the learning objective that they've defined. And then the last piece is a reflection on the process, on the planning, on the implementation. What would you keep? What would you change? What would you do differently? What are some teacher moves that could have maybe been tightened up? And what did you think you did really well? And it's a wonderful way for teachers to demonstrate that they are competent teaching something and not have to be tied to having to take a class at one of our wonderful university partners. So I'd like to segue a little bit and talk about how we set the norms for what is expected in Utah. We primarily do that at the State Board of Education through guidance documents, and guidance documents come through committee work. We are very intentional about inviting all sorts of stakeholders that represent all different stakeholder groups. And we even include students in the process. What do they want to experience in a math class in high school? And what does that look like? What are students doing? What are teachers doing? What are teacher leaders doing? So I've decided we have a whole litany of guidance documents. I just picked the top 4 that really set the culture in Utah. So we talked about the portrait of a graduate. Those were those 13 competencies, with academic mastery just being 1/13 of the puzzle. The others included creativity and problem solving, resilience, other other aspects, the qualities that we think make an engaged citizen by the time they graduate high school. That is our guiding star. Everything that we recommend has to include some tie back to our portrait of a graduate. So the first piece that came out of that is, if these are the 13 competencies that we want in Portrait of a Graduate, that we want all students to graduate with in order to be engaged citizens, what does that look like in a classroom? And that is this personalized competency-based learning, PCBL. Sometimes it's called student-centered learning or learner-centered classrooms. And I'm going to advance the slide and just show you a snippet. It's quite a large document, but it highlights 5 key components that need to happen in any learning experience or learning environment in order to meet the competencies in Portrait of a Graduate. We have the culture of learning, learner agency, student choice, demonstrated competency and assessment, customized supports, and social emotional learning. So these are 2 documents that are kind of generic. They apply to all content areas. What's been really fun as the secondary math specialist is to say, how do we take Portrait of a Graduate and personalized competency-based learning and apply that to a math classroom? What does that look like in secondary math 1? What does that look like in secondary math 3? What does that look like in a math department? So our first document that we have that spawned out of these conversations is called Utah's Pre-K through 12 Mathematics Vision. And this document was created over several weeks several months. It took almost 8 months to create this with our wonderful leaders. We relied heavily on the core standards that we defined, what gets taught in each of the grade levels of mathematics, as well as the National Council for the Teachers of Mathematics. They have their standards of mathematical practice, what students should be doing in order to engage with mathematics in a way that research and evidence says is high quality. And then we also relied on the National Council of Teachers Mathematics standards for the mathematical teaching practices. These are the way that research and evidence says best meets the needs of students. And then it's fine and dandy to talk about research and evidence base all day long. Sometimes these can be high level and hard to take these and, see how you can utilize them in your sphere of influence. And so the page that gets the most views on this pre-K through 12 math vision is this second page. And it really goes through, what are students doing? What are teachers doing in an environment that looks like this? And what are leaders doing? And it's explicit. And it calls in those standards for mathematical practice, the ways students are supposed to be engaging with the mathematics, and the way teachers are supposed to be teaching the mathematics, the mathematical teaching practices. And my very favorite part is our leaders feel strongly about having an asset-based environment. Too often, especially in mathematics, we are trained to look for gaps and deficits. And we in Utah feel the Utah way is to flip that. We are more interested in student strengths. And when a need arises, we jump there to support that need, but we are not actively drilling or looking for weakness. We are capitalizing on the strengths that a student brings to the mathematics classroom, and we are using those strengths to further their learning and give them access to rigor and rich mathematical experiences. The last guidance document that came out of the math vision is called the Pre-K through 12 Math Framework. And this was just published this time last year. And this is so the vision is just kind of a 2-page overview, what you can expect in Utah, what is the Utah way for teaching mathematics in any grade level. It's because it's pre-K-12. And this framework goes into more detail about the expectations that we have in Utah for secondary math experiences. This is a 39-page document. It has to be tied to evidence or research. And I'll talk a little bit about the structure in a minute. So our committee of stakeholders decided that we have these 4 categories of what it takes to be a really great teacher in our secondary math system. We have instructional leadership, asset-based learning environment, instruction and intervention, assessment and feedback, and professional learning. And I'll scroll down here a bit and show you how it's structured. So we have an introduction. The introduction is very much like the vision document that I shared. And then we have our first bucket, asset-based learning environment. Each of these is structured so that you're given an overview about what it means. What is an asset-based learning environment? I've never heard that term before. Quick overview. And then we always have resources at the end. And the resources look the exact same as the rubric down here. So if you wanted resources on asset-based learning environment, critical indicator A, you click on this document and it looks just exactly the same, except for instead of these numbers here, you have resources that you can go to for more information. And so each area has between 9 and 15 critical indicators. They are all tied to evidence and research base. And then it's structured so that anybody who picks up this document, it could be a teacher, it could be a principal, it could be a department chair, it could be me at the State Board of Education evaluating my entire system. They think about what they're trying to evaluate, and it's a self-reflection process. Are students, teachers, leaders, and community partners demonstrating their belief that all students can achieve mathematically at high levels? No excuses, no exceptions. And you think about that. And you say, based on this rubric, which our leaders were very intentional about making asset-based, where does what you're evaluating, your classroom, yourself, your department, where does it fall? And then you have a place to go for additional resources if you need, if that's something you want to work on and get more information about. So I'd like to end by talking a little bit about the future of Utah's secondary mathematics landscape. We have a lot of really great things going for us that show some wonderful student outcomes. And just as with everything, there's always room for improvement. So we talked a little bit earlier about those alternative sections. First of all, if 51% of students are opting out of secondary math 3, perhaps that's an indicator that something needs to be changed in secondary math 3. We are busy having those conversations in stakeholder committee groups, and it's very, I say busy, it's also very messy. What should all students know, and where is the place where students should have choice to pick studying a mathematics that interests them? And finding that line is, it's hard work. And there are a lot of feelings that surround all of these conversations. And so we've started that process. We have invited lots of stakeholders to the table. We've invited mathematicians and also math adjacent people to be part of the conversation, because in secondary math, we are training engaged citizens. We are not training mathematicians necessarily. They get to make that choice when they go to high school or to college, right? And and everybody becomes a math major. One of the places besides secondary math 3 where there's a little bit of an issue that we're looking at as well is in those alternative selections. So if a student opts out of secondary math 3, they can take one of those other courses from that box there that's listed alternative selections. And they are great courses. And actually, they look really interesting. Math of personal finance, computer programming, accounting, medical math. I have a high school student. Those classes are really appealing to her. They seem relevant, they seem engaging, and they seem to teach her skills that she is interested in learning about mathematically. As the mom of a teenager, I know every day that teenagers change their minds. One day one day my daughter wants to go to college. One day she wants nothing to do with it. One day she wants to live in a van and live her rock climbing dreams out. They are so polar. And I think our stakeholders are telling us that we need to set our kids up for success, because one day they might want to go to college. It might not be tomorrow, but they need to have the skills that empower them to to transition seamlessly into the college world should they choose that option. We know that some kids are really big on college and then they need to enter the workforce. And we want to make sure that our high school math experience sets our kids up for success in whatever they choose. I really thank you for listening about the Utah secondary math pathways. We've tried to work really hard to increase opportunities for everybody in our system and to empower our students and our families to make really informed choices about becoming engaged citizens. Thank you so much. Hello, everybody. Thanks for joining. I saw a lot of questions come through in the chat, and I am so grateful that I have my Utah partners here to help me answer them. Jolie, it's so good to see you. So, wonderful question about our dual enrollment courses. They are taught by a high school teacher or a faculty. Sometimes the institution of higher education that oversees dual enrollment in that area will make a high school teacher their faculty, and sometimes they will just allow a high school teacher to teach that class. They need a secondary math endorsement, which is approximately equivalent to a major in math and some education training. And we have really great data that shows that our high school teachers are doing amazing things in that space, as well as our higher ed partners and professors. I love seeing all of the remarks about the Portrait of a Graduate work. That's truly been an instrumental piece of guidance for me at the state level and all the other content area leaders to have these conversations that we need more than just content knowledge and content experiences in our high school classes. How do we develop critical thinkers? How do we develop digital literacy? How do we develop communication skills? That's been a really nice opportunity to bring some of those, and I don't like the term soft skills. I think they're really important, and I think that's kind of demeaning to what they are, but it's the only term I know that describes them. So it's been a really nice way to bring the soft skills back to mathematics and kind of humanize that mathematics experience. Oh, great question from, I think it's Rebecca. A student decides to take the extended topics as a freshman, but then decides to go into the foundation course for their sophomore year and then wants to jump back into that extended pathway. That's perfectly acceptable. Students can bounce around. Sometimes districts will offer a bridge course that will help the students catch up on some of those pre-calculus topics that they missed. Sometimes there'll be extra sessions during the school day or over the summer where students can catch up on that work. It's not that difficult since we split up the pre-calculus topics between the 3 years. It's like a third. It's not that difficult for a student to catch up and get back on board. Well, I'm so grateful that you joined me today. We're running out of time. My email address was on the last slide, lindsey.henderson@schools.utah.gov. I would love to hear from you and look forward to any opportunities that we could have to collaborate. Thank you.